Hello everyone and Happy New Year. My name is Behnush Parsa and today I'm presenting to you a multitask learning approach for human activity segmentation and ergonomics risk assessment. We are solving the problem of human activity evaluation as well as human activity segmentation in long videos with a multi-learning task approach. We are considering indoor activities as well as using human skeletal description. Human skeletal description is a non-Euclidean data, and therefore we are using graph convolutional network to represent the features. And for the first time, we are bringing in ergonomics risk assessment to human activity evaluation problems. This is an important metric in industry for evaluating the ergonomics risk corresponding to the works that workers are doing. Our proposed multitask learning pipeline takes the 3D pose from videos and feed that into spatial feature learner that has layers of graph convolution. And the resultant feature goes into the activity segmentation unit as well as the ergonomics risk score predictor. And the output of the model is a semantic segmentation of the video as well as the ergonomics risk associated with those activities. In the multitask learning with embedding, we fuse the action classes to the spatial features that are output of the graph convolutional network and feed that all together to the ergonomics risk score predictor. We are testing our algorithm on University of Washington indoor object manipulation dataset as well as Technical University of Munich kitchen dataset. As you see in TOM dataset, the camera angle is from top and there are a lot of self-occlusion happening. And therefore, the quality of pose and information is not high. And we intentionally use this dataset to show that graph-based convolutional networks cannot perform well on these type of datasets when we don't have good quality pose information. The ergonomics risk assessment model that we use is called rapid entire body assessment. This model creates higher ergonomics risk score when joints are getting closer to safe range of motion. As I mentioned, the 3D skeletal pose goes into a graph convolutional network architecture that has multi-layer graph convolutions to extract richer spatial features, and then the resultant feature goes into the encoder-decoder temporal convolutional network for the activity semantic segmentation, as well as into the regressor for postural assessment task. And the final loss is the sum of weighted losses of the two tasks, and we also learn the weights of the two loss. We also test the human activity segmentation task on its own because we are interested in seeing how a graph convolutional network with EDTCN performs comparing to the previous work that are showing the results on these two data sets that use the VGG-based backbone. We see that for UDOC data set that we have high quality pose information. The results are comparable and even in some cases better. But for TOM dataset, VGG-based features that are context-rich features perform better. And we also use test the single task human activity evaluation model. And you see here that it almost learns nothing. And this is where the multitask learning approach helps. And we see enhancement on the postural assessment task, considering that the rebar scores across the time have a highly nonlinear profile. So in this work, we showed that graph-based activity segmentation models for long videos perform well if we have high quality pose information. And there is promising future for graph-based multitask learning methods for human activity evaluation in long videos. In future, we plan to incorporate human body dynamics by designing biomechanical-based models, as well as leveraging attention-based design to identify the role of human joints. Thank you all for your attention.